Hey, in this video we're going to be covering work problems when it comes to filling and emptying a three-dimensional object. So our problem here says that we have a tank in the shape of a cylinder and it has a radius of 10 meters and a depth of 3 meters. So our first prompt is to find the work required to empty a full tank just as is. Here's our traditional equation we're going to use for these types of problems. You've got the integral from a to b, rho times g, and then a of y and d of y. Our rho is our density of water, which it said was standard, so that's going to be 1,000 kilograms per meters cubed. And then our g is acceleration due to gravity, which is going to be 9.8 meters per second squared. And then our area formula, since we're looking at a cylinder here, is going to be pi r squared. And so right off the bat, we can fill in those three variables. We've got 1,000 times 9.8 times pi, and then our radius it said was 10, so pi 10 squared, and that's going to give us 980,000 pi, and that's going to be a constant that we can use in the rest of the problem, basically. So we plug in our 980,000 pi and then find the integral of y dy from 0 to 3. You can do that in your calculator or fundamental theorem of calculus, but that's going to give you 4,410,000 pi joules as your first answer. Our second prompt is asking to find the work required to empty a tank that has 2 feet of water depth in it. And our first step here is going to be convert 2 feet to meters. So 1 foot equals 0.3048 meters, and so 2 feet equals 0.6096 meters. So, we've got 0.6096 meters of water in the tank already, and we're trying to get it down to 0. Those are your A and B. You can bring down that constant from earlier, the 980,000 pi. And then what you're going to be multiplying by is 3 minus y, since 3 is the full depth of the tank. Same thing, you can put that in the calculator and come over here, and it's going to give you 1,610,134.04 pi, or if you distribute that pi in there, you're going to get 5,058,385 joules for that second part. And then our final part of this question says that the pump is sitting 5 meters above the tank, and now we have to find the work required to empty the tank once again. So this part is going to stay the same from earlier. We've still got 0 to 3 as our A and B, 980,000 pi, and then the only thing that's going to change here is instead of just multiplying by y, you've got y plus 5, since you're adding an extra 5 meters of space where the pump is. And then same thing, you can put that in the calculator, and you're going to get, again, I can't read, I think 110,000 pi joules, or if you distribute the pi, it's going to be, 60,035,835 joules.